Okay, ladies and gentlemen, good morning. So we are going to start, I shouldn't say start, or I guess we're going to start, but this is something you guys have seen probably as far back as the 5th grade, what we call the order of operations, okay? So we know that when we have an expression that it has to be evaluated in a particular way. And as far as, in person we get into a little discussion about why, but basically it predominantly for the tie-ins with something like science, right? When we're talking about formulas, when you guys in a few years maybe will study physics and chemistry and things like that, we have these formulas, and if we don't evaluate these formulas correctly as far as which operations are evaluated first, we get vastly different results, which if you're thinking about doing something, again, scientific, thinking about things that are maybe nuclear, things like that, the results of something that's incorrect could maybe be disastrous. So we want to make sure that we know the correct order of operations so that we can evaluate these expressions correctly. All right, so let's do a little recap of our last lesson here. We'll go over the do now. So the first question says 10 more than twice a number is 3. So more, right, we've got that addition. Twice a number, we have that 2x. And is, we've got our equal sign. So how am I going to do just this first part, right? 10 more than twice a number. Well, here's my twice a number. Here's 10 more than twice a number. And all we have to do for is 3 is put equals 3. For the second one, we really need to reach back to the end of that previous lesson, right? So I'm going to go back to my example where I've got this pencil in my hand, right? I've got all of this pencil. I have 100% of a pencil in my hand. Somebody gives me 3% more pencil. Now I have 103% of my pencil. Now what is 103% as a decimal? Well, we have to divide that by 100, which is 1 300. So if it's that much of a number, I have 103% of my number, I have 1 300 of that number. All right, so let's talk now about number 3. So 13 is, so of course we have our equal sign, right? We have less than a number, or less than, in this case, 3 times a number. So we know we're going to switch the order of the terms. Right, if I want 8 less than 50, it's not 8 minus 50, it's 50 minus 8. So we have to switch the order. So let's talk about 3 times a number being 3x. Let's talk about 8 less than that being 3x minus 8. And that whole thing is 13, so we're going to set that equal to 13. So we're going to start talking about order of operations, and we're not talking about PEMDAS, okay? PEMDAS to me implies 1, 2, 3, 4, 5, 6. So my students that have the PEMDAS ingrained very deeply in their brain, when they come into class, they say, well, PEMDAS, we're going to do our multiplication before our division and our addition before our subtraction. And they say, because PEMDAS. And I say, PEMDAS is not a thing, okay? So the order of operations is 4 things, right? Sometimes people do GEMDAS for grouping instead of parentheses. I don't like that any better. So we're going to say number 1 is our parentheses, which includes brackets. Brackets are just another group of parentheses. 2, we're going to evaluate our exponents. Exponents is just a kind of fancy way of representing multiplication, which is our 3rd pillar here, and this should all be in our notes, guys, which is our multiplication and division from left to right as it appears. So do we always do multiplication first? No. Do we always do division first? No. We do them as they appear left to right. And finally is our addition and subtraction, also done from left to right. The order of operations is not a hierarchy of 6 operations, it is only 4, and we will talk about it in great detail today. So let's go through it. Sometimes students, and I don't necessarily love this, but if you need to do it, then by all means do it. And I already made a mistake because I generally do not do this, but let's take a look at it. And they do a little checklist. They say, where's my parentheses? And we say, well, we don't have any, so let's get rid of that. Where's my exponents? We don't have any. Next, I have to do multiplication and division together from left to right. So I'm scanning from left to right, and the first thing I encounter is this division. So it doesn't matter that, PEMDAS has M before D. We do them together from left to right. So I do my division, which gives me 4. I am literally bringing down everything other than what I underlined here. So -7 plus, and then the times 3. So it's kind of like this exists in a bubble and everything else comes down. Now I'm not done with this multiplication division step. I'm going to do that multiplication division step from left to right, giving me 12. Now I've got -7 plus 12, which is going to give us +5. Guys, this is the way that I want you to show the work in your notes. This is the way I want you to show it for your homework, okay? We're not going to just put an answer. That's going to tell me you used the calculator and you just put it in and got your answer. You get no credit for that. I need to see all the steps. If I see a bunch of steps and a wrong answer, I will easily be able to identify where you made your mistake. If I just see you put equals 7 or equals 5 or equals anything like that, that tells me literally nothing about your comprehension. So make sure we are working, for one, working down and not across, right? I'm not putting equals something else. That's called stringing. Mathematically, that doesn't work. So try, and it's not, you're going to probably hear this a lot, it's not that it's my way is the best way. This is the way that you will be expected to do it on Regents exams and things like that. All right, so let's move on here. So thinking about my little checklist there, I do have parentheses now. So I'm going to evaluate what's in my parentheses. And again, everything else comes down exactly as is. Now I can evaluate my exponent, as that's my next part. And again, everything comes down exactly as is. Now I'm going to do my multiplication and division. So the only thing I have here is multiplication, which I will do. And the last thing that I've got to do is subtraction, which I will do here, and that's going to give me negative 23 as my final solution. All right, so same thing here, guys. All right, so we've got those parentheses, so I'll evaluate what's there, and I will bring everything else down as is. Honestly, guys, for something like this, if you wanted to do the exponent and the parentheses at the same time, since they're essentially independent of each other, that would be perfectly fine. Now I'm going to evaluate my exponent, 2 cubed, which is not 6, right? 2 cubed means 3 powers of 2, as in 2 times 2 times 2, which is 8. We will bring everything else down. Now our multiplication and division must be done from left to right. So if I'm scanning from left to right, the first thing I encounter is this division here. So I'll take that back. So I'm going to do that division first. Now there's a couple different ways you can think about this. We can think about it as 24 divided by 8 and bring down the subtraction sign. More correctly, it is negative 24 divided by 8, and the sign of your answer is the sign of the operation. It is a subtle difference at this point, and you're probably going to say it doesn't make a big difference. When we start solving and checking equations, it will make a big difference, so I want to try to hammer that out now. This is really negative 24 divided by 8. Now, negative 24 divided by positive 8 is negative 3. Now, I do not bring down the negative sign because I already used the negative sign when I evaluated negative 24 divided by 8. Now, if everything I said completely confused you and you don't like it, then just scrap it for now and just do 24 divide 8 is 3 and then bring down the subtraction sign. Your result will be the same. So now I'm looking at my multiplication step, which is 3 times 0, which is 0. And of course, 25 divided by 0 is going to give us 25. All right, let's talk. Actually, the next lesson is going to be specifically about parentheses, specifically what happens if you've got a term outside parentheses. But we're going to talk about something like this, right? What's the difference between these expressions? So in class, I would ask this question, and someone's going to say, well, in the first one, the exponent's inside, and the second one, it's outside. And I'm going to say, well, that really didn't answer my question, right? Mathematically, at least. And then somebody will say, well, in the first one, the 3 is being squared, and then it's added to 5. And in the second one, the sum of 5 and 3 is being squared, and that's the correct answer. So following order of operations, within my parentheses, I still have to follow order of operations. So within my parentheses, I've got addition and an exponent. I'm definitely going to do my exponent first, or evaluate, I should say, my exponent first, which gets me 14. Here, I do what's in the parentheses, which is my addition. I can keep it in there. And that should be a 2. Apologize for my handwriting, as I often will. And we end up with 64. So a very big difference by just taking the exponent, moving it inside versus outside. And again, mathematically, the difference is in the first expression, only the 3 is being squared, whereas in the second one, the sum of 5 and 3 is being squared. All right, little kind of detour here, right? Not so much an order of operations thing, but it is going to tie in with our integer rules. So let's talk about this, right? So in the first one, I've got negative 2 raised to the first power. Well, that's just 1 power of negative 2. The second one is negative 2 squared, which is negative 2 times negative 2. Now we should know that when we take the product or quotient of two negative expressions, that the product is positive. Now what happens if we add another one? Well, now it becomes different, because when I evaluate this, that gives me 4, but now I also have to multiply by this other negative 2, which gives me negative 8. And when I take that and add another power, now I'm multiplying that by negative 2, it's giving me positive 16. And if I do that again, it's negative 32. So as we can see, the powers are going to alternate. So let's fill in this little table at the bottom. If a negative number in parentheses is raised to an odd power, I'm going to end up with, let's take a look what we've got, a negative product. Right, product because it's the result of multiplication. And obviously all the even numbered powers give us a positive product. And we always try to break that down. I always try to find someone that can do a good job verbalizing that, right? So in other words, we know that each pair of negative numbers, as we saw here, produces a positive product. So if I have a negative, if I have an even power, that means I can pair up my numbers, my negatives, with nothing left over. I'll have an integer number of pairs. But what happens if I have an odd power, like negative 2 to the fifth? Well, I can pair up two pairs of negative 2's, but I'm going to have a negative 2 left over, which is going to make my result negative. So an odd power, and this is only if the parentheses are there. We will revisit this, I believe, in the next lesson if they're not, and it will be different. I don't want to throw them both at you at once because that becomes a little confusing. But assuming there are parentheses there, which there generally are, and especially if you're checking an equation there would be, then these rules are going to be true. All right, so let's think about this one. So what is being squared? The entire value of the expression. So the final the power of 2 out there, we're not going to do that until the very, very, very end. So I'm working within my parentheses here. So I see some addition, subtraction. Clearly my exponent comes first. So now I've got 7 plus 8 minus 11 plus 3. And that whole thing is being squared. So if I want to do this by the book, I'm doing my addition and subtraction from left to right. So I'm going to do my addition. And I'm going to do my subtraction. Now I'm going to do my final addition. But really, what I'm okay with you guys doing is, once you get to this point here, where it's just going to be addition and subtraction, you can do it all from left to right. So I'm going to kind of dictate it to you, right? So if that whole thing, if there's any other operations, it won't work. But if it's just addition and subtraction, or I guess multiplication and division, though it's a little harder to do in your head, we can do them from left to right. So let's look at that. 7 plus 8 is 15. 15 minus 11 is 4. 4 plus 3 is 7. So if this was my homework, I'll be consistent here. I would do step 1, which is this. Step 2, which is doing all the addition and subtraction, and then step 3 over here is evaluating the power. Now I found that a lot of students like this. They like to see it step by step, and if you're one of those students, absolutely, that's great. But for me, as far as what I need for like classwork and homework, when you get down to just addition and subtraction, I'm fine with you doing those in one step. All right, so for this one, I'm going to ask the question, and I don't know that you guys all got to it last year necessarily. The question is, what happens when we raise any non-zero number to the 0 power? And the answer is 1. And I always have a couple students, and I say, wow, I'm really impressed. And I say, do you know why that is? And very rarely do I get an answer, once in a while. So when we get to our laws of exponents in hopefully January or so, we're going to break this down a little bit further. I'm certainly not going to just tell you guys mysteriously that it's 1 and just kind of leave you hanging. So I'm going to show you something simple, and I'm going to go into this again in more detail when we actually do laws of exponents. But let's think about our powers of 10 for a minute. Right, so what's happening as I move up my chain from 1,000 to 100 to 10, right? So someone always says, well, you're losing a 0. And I said, I don't know what that means, I'm losing. Things in math don't get lost, right? That's not actually what's happening. And then somebody will say, when I say, well, what's happening mathematically? And we're going to say, we're actually dividing by 10, right? We're dividing by y10 by the base. And if we did it with something like 2, and I guess I misspoke, I am going to get into it here, and I will do it again when we get there in January. It works the same way, just to illustrate that point, right? So as I work my way up, I'm dividing by the base, whatever that is. So my base is 10. If I divide by 10, it gives me 1. My base is 2. If I divide by 2, and again, that's going this way, I get 1. This will work with any numbers, fractions, decimals. So that's the reason, right? And sometimes our teachers don't necessarily maybe have the time to go into it, but that's why any number raised to the 0 power is going to give you 1. So if you do see a problem in your homework that involves a 0 power, you can safely just put 1. I don't need to see any work for that. All right, now we've got parentheses and brackets. So those brackets are just a separate set of parentheses. So we're going to evaluate inside the parentheses here using order of operations. So I see tons of addition and subtraction, but I also see a group of parentheses with an exponent. So that's where I'm going to go first. And I'm going to bring down those brackets, and I'm going to bring everything else down exactly as is. And now in my parentheses, I'm going to do my exponents. Now this is going to tie in with my negative numbers raised to a power. So what's negative 3 cubed? It's negative 3 times negative 3 times negative 3. And I can write it down up here. So what's negative 3 times negative 3? Well, that's going to give me positive 9. Now what happens when I multiply that by negative 3? It gives me negative 27. So that's my next line down here. So now I'm looking at negative 5 plus negative 27 minus 9 plus 41, and that whole thing is being squared. So let's go through this left to right. Negative 5 plus negative 27 is negative 32. Negative 32 minus 9 is negative 41. And negative 41 plus positive 41 is 0. And hopefully we know that 0 squared is simply 0 times itself, which gives us a final answer of 0. Okay, guys, so far so good here today. So that's going to be your homework. So for each of these guys, I expect it to look something like this. Obviously, this, some questions will have more operations than others, but I do not want to see this. Okay, I do not want to. Sorry. So again, guys, we are going to essentially do this, like I said, just like we did in class. Okay, we're showing all the steps. We're working down and not across. Yeah, and again, go back if there's anything, any questions or concerns, you go back to the video. Beyond that, guys, we talk about it on Google Classroom, right? So best thing to do is do as much as you can, circle the stuff or write me little notes where you have questions, upload it, let me know you had a problem with it, as opposed to just saying I had a problem with number 5, right? Saying I have a problem with number 5 isn't really that specific to tell me what exactly you had a problem with. If you show me the work and then you have a little question mark at a particular step, that's going to be really effective in kind of guiding me to help you. Okay, so again, guys, this is going to be done on a piece of loose leaf that you're going to upload to Google Classroom when you're done. Any questions or concerns, we talk about it there.